in this episode of the Critical Oxygen podcast. We have a tendency to take things a little bit too far than what they're actually like useful for. But so the whole point is that, you know, with RER, we don't know when that excess CO2 from excess buffering within the, you know, like within the blood is actually occurring. Hi, everyone. Welcome back to the Critical Oxygen podcast, where we help you optimize your physiology and maximize your athletic potential. I'm your host, Phil Batterson, and today we're joined by continuing guest host, Dr. Robbie Jacobs. Dr. Robbie Jacobs, welcome back to the show.
Thank you, Dr. Batterson. I have some good news to share with everybody.
Yeah, I'm excited to hear this. You kind of teased it when we were talking offline, so what is it?
So I finally heard yesterday that our sub 2-hour marathon paper was accepted in the Journal of Applied Physiology.
Heck yeah. That's no, I'm super excited to dig into this because for those of you who don't know, like I barely know, it's like a modeling paper, right? With carbohydrate oxidation, like fuel oxidation, as well as performance variables.
Yeah. So it was during COVID where all scientific presentations were online. And so one of the benefits of that is that I was able to join in on more presentations than I would have otherwise, you know? And so Dr. Michael Joyner was giving a talk, I think at SMU. So Southern Methodist University in Dallas. But we were invited because their department chair is good friends with our department chair. And I remember Dr. Joyner talked about all these characteristics that are necessary in order to be able to run a sub 2-hour marathon. But the whole time I'm thinking like fuel utilization, the fuel availability is key, right? And when we talk about endurance performance, like fuel is one of the main topics you need to discuss. And so I just remember I asked a question about, I was like, how did they fuel these athletes? Because I just anticipated that you would need a significant amount of carbohydrate, right, to run a sub 2-hour marathon. And he just kind of told me, he was like, oh yeah, they did mixed glucose, fructose solution at around 90 grams per hour. Just recommendation. So I was like, okay. And at the same time, I was working on, so I wanted to use the measures we get when we're looking at respiratory control from high resolution respirometry in the samples. I wanted to use those values and try to compare them to a VO2 difference, so arterial venous differences across the leg, or look at how they compare to extrapolations from magnetic resonance spectroscopy, which is looking at different concentrations of phosphate across, so like ADP, ATP, AMP. And so I just kind of became well-versed in, or not well-versed, I should say, became familiar with how respiratory rates can be used to discuss rates of substrate oxidation. I was like, I'm just interested. I want to know how much carbohydrate is necessary to run a sub 2-hour marathon. And had 2 new master students. And so one of the master students was interested in taking that project on. And yeah, a 2-year extravaganza that just finished yesterday. And it's cool. I was really, really happy about this acceptance. And I don't remember being this happy about getting a paper accepted. I haven't been
other
that
than
happy.
my master's degree paper.
But in general, no, it's even
No,
hot mitochondria paper, which I tell everybody that I think when my career is done, I wouldn't be surprised if that's my greatest contribution to science. I wasn't even as happy when that got, and I think it's because this was a little bit out of my field of expertise. It was very much sports nutrition. And part of the review process was almost like comprehensive exams,
Right.
because I would get really advanced human metabolism questions, or questions about human metabolism, that I easily spent 100 hours in the review. And I feel almost like I earned another degree
Mm-hmm.
in human metabolism from it. And I think that that's maybe why I was so excited. But it's a really fun study, because we hypothetically develop a scenario in which we model elite male and elite female runners, and we take all the physiologic characteristics that are necessary to run a sub 2 hour marathon. We apply them to those runners.
Where did you get those physiological characteristics from?
Well, so I confirmed them with one of the co-authors, Dr. Brett Kirby, and he definitely provided. So Dr. Brett Kirby is a co-author on this, and the Breaking 2 project at Nike was pretty much, as I understand it, it was a lot of his brainchild. I mean, even when Ineos actually broke the 2 hour marathon, Brett was right there. Like, right. Brett was on his bike. You see him right there. So he was a part of this. And so I wanted to have somebody that could come across and be like, not possible. That's not likely. That's not how it is. And so I definitely had Brett on board, and he was vital in maintaining the legitimacy of the model, because my expertise is in, the porcelain bowl. What'd you call it?
The porcelain throne.
Yeah.
We call it a porcelain throne because I think at this point, right, a lot of people are sitting on the toilet and talking about their research and stuff like that. That was a total brain fart on my. But yes, the ivory tower.
You didn't mean to say that?
No.
Really?
But it turned out to be something funny, because I mean, if you think about it, right, people are tweeting, like, most likely from their porcelain throne.
And that's by far my biggest weakness is my experience with application. And in general, these models were elite, the top of the top. So I work with athletes not at this level. I don't know. I mean, I guess I've worked earlier during my PhD, I worked with a little bit with a Danish cycling club, and one of those riders went on to get gold in the London Olympics. But I needed somebody that could really verify the numbers that we used. And so I modeled lower body and hepatic glycogen stores. I modeled incomplete muscle activation during running, and everything. And it comes out that even the highest rates of carbohydrate intake in these elite athletes, and they're starting off with absolutely topped off glycogen stores, it doesn't look like completing a sub 2 hour marathon is even possible with just carbohydrates alone, meaning that most likely these individuals that are running around this pace, or faster than this pace, must have abnormally high, or almost like anomalous, skeletal muscle mitochondrial content.
Right. For fat oxidation to be able to continue to occur. Yeah.
Yep. Exactly.
Yeah. I've been thinking a lot about this, since you kind of introduced this to me, a little while off the books and all that. And something that I was thinking about is, like, so if you're taking in, carbohydrates, you're taking in exogenous carbohydrates, most likely you would then see, RER go trend towards 1, if not get up there. But what happens? Like, is it like when we have high carbohydrate, that's being absorbed, do we just shut down fat oxidation within the mitochondria, or is that still going on, just to a much lesser extent?
I don't know, but I find it hard to believe that we shut down fat oxidation entirely.
Yeah.
I really find that hard to believe. And actually, my hot mitochondria paper started out to prove that. That was the initial goal with that paper, is I wanted to take all these high resolution respirometry samples and demonstrate that, especially slow twitch muscle. I was like, slow twitch fibers are never not going to use fat because they just don't have the ability for the ATP demand to ever outstrip their ability, their reciprocal ability to provide ATP via fat oxidation. However, I think I was a little short-sighted in understanding slow twitch fibers' use of the lactate that's being released from their fast twitch neighbors.
But I will add this, because something that Dr. Newsom would say to me is fat burns in a carbohydrate flame.
Totally.
So
I don't know what that means. I've heard that. So my professors would tell me that, and I've tried to look that. Yeah, I want to know. I've tried to look this up several times, and I can't find the answer.
This is what I think it means. So there's a process, and I can't remember exactly what the process is, but if you get high pyruvate during times where ATP demand is low and adequate fat is within the mitochondria, you can actually convert that pyruvate by adding another carbon to it, to oxaloacetate, and then that oxaloacetate can then be merged, or I don't know, I can't remember, synthesized with acetyl-CoA to make citrate. So that acetyl-CoA is coming from beta oxidation. So that's what people say is because we're almost always, and this is where I think we put too much into RER sometimes, is like
totally.
we're looking at whole body, fat, carbohydrate oxidation based off of how much oxygen, how much CO2 is being consumed and produced, and that's not telling us at a molecular level what's actually happening. You're always churning over glucose, you're always churning over fat.
Yep.
And so in times where either demand is low or fat is high enough, fat is a super efficient fuel. I'll say efficient fuel in quotes, because it holds a lot of energy within a small-ish carbon strand, right? Totally. So if we are breaking down fats and using that primarily for acetyl-CoA, that's actually going to inhibit, then pyruvate dehydrogenase, and push pyruvate dehydrogenase to then synthesize pyruvate to oxaloacetate. It does cost 1 ATP from, if I can remember my bioenergetics correctly, but
your biochem.
Biochem correctly. But if we're doing that, it seems like, it's worth the cost. And especially if we have these individuals who I'm sure they have super, super high or super, super well-developed mitochondria, along with, both volume and function. And within that function, you're going to have a metric buttload of fatty acid oxidation enzymes. And, so if you're able to, as long as you're able to transport fat adequately into the mitochondria, whether that's, and, that's why people, will supplement with like L-carnitine and stuff like that, to be able to keep fat coming into the mitochondria for higher and higher, outputs. So there's got to be fat oxidation going on. And I think where things get muddled and where things, where you have to remind yourself is like, we say, okay, well, when an RER gets to 1, then we're burning only carbohydrates. Yeah. But what I would challenge for people is at what point, we say, okay, excess CO2 production because, or excess CO2 production because of buffering. But when is that actually starting to play in? We can't determine that because we don't know where the CO2 is actually coming from. So it could be giving us anomalous measures, right?
Totally. Oh, it does. I think so. RER is an imprecise tool that is quite functional, right?
Yeah.
For sure. Totally. I don't think RER, it doesn't reflect adequate protein oxidation and I think fat oxidation at higher exercise intensities. Mm-hmm. Yeah, I'd agree.
Yeah, and I just think I want to implore people to like take every measurement. I've been starting to talk about all of these measurements on my Instagram as like, what is lactate, blood lactate, and what is it telling us? What is RER and what is it telling us? Because there are limitations to every measurement. Mitochondrial respiration, right? We, especially isolated mitochondria, we take a sample of someone's muscle that's like, a fraction of a fraction of a percentage.
Vastus lateralis,
Yeah,
even.
yeah,
Not even
exactly.
like a muscle, typically that muscle.
And we pull the mitochondria out.
Yeah.
The mitochondria are, ripped apart, put back together, like deformed and all this stuff. And we've talked about this. It's amazing. They still can even do, any sort of respiration, right?
Right.
And yet we use that as a way of measuring, say, mitochondrial function. And we take it, I think we have a tendency to take things a little bit too far than what they're actually like useful for. But so the whole point is that, with RER, we don't know when that excess CO2 from excess buffering within the, within the blood is actually occurring. So
theoretically, it should be around LT1, right? And it's going to really be increasing around the second, but it should start to accumulate at LT1.
Yeah. But then it depends. Okay, well, how well developed are your mitochondria? Because if your mitochondria are really well developed, then they're going to continue to sequester hydrogens that are being, produced from ATP hydrolysis. So it's all of these. It's the human body is so much more complicated than what we actually make it out to be, and we try to simplify it. So I think that our little pea brains can actually understand
can make sense of it.
Yeah,
100%. I totally agree. And the other main finding with the study really is that higher exogenous carbohydrate intakes during exercise more beneficial for elite female athletes respective to their male counterparts, because they tend to be lower body size. So that's going to be less muscle, smaller livers, so less glycogen. And glycogen is the preferred carbohydrate source because it's going to save you an ATP for every individual glucose that is oxidized from the glycogen stores. Utilize the ATP. And so because of that, these higher rates of exogenous intake preferentially more beneficial to female athletes.
And so we'll go over this paper in great detail. Like we'll do a journal club on it. I think that would be super fun. And so my last question on this, and then we can kind of move to the topic we were kind of planning on talking about today, is, we were going back and forth about, okay, like the research kind of shows that 90 grams of carbohydrate is kind of like the maximal for benefits. That I'm saying the research, but there's been some papers to suggest that maybe 120 grams of carbs is a little bit better in terms of maybe getting rid of or reducing the amount of metabolites that remain in the blood after ultra marathon or a marathon, as long as you can tolerate it. So with this modeling study, what did you guys find in terms of how much carbohydrate oxidation, like, both intake and then actual oxidation was actually going on?
Well, so the model didn't account for that, but at the end of the paper, I do assume, so we switch the model. So I fix it at assuming an exogenous rate of carbohydrate oxidation. And I then find the RER, which is representative of exercise intensity or reflects exercise intensity. Mm-hmm. And I did that for 90 grams per hour and 120 grams per hour. And assuming that the current world records were set or achieved at 90 grams per hour, increasing intake from 90 to 120 grams per hour would improve, theoretically, could possibly improve the female record by 2.66% and the male record by 2.23%. And so while the model didn't it can't account for that direct question that you asked. We can get an idea for how beneficial different intakes of exogenous carbohydrates may influence performance. Yeah.
Yeah. Yeah. And kind of in one of our other conversations, you were saying too that, if you intake 90 grams of carbohydrate per hour, you're actually only oxidizing what, like 60 grams of that?
So I calculated that too. I'd have to pop up, but I calculated the curvilinear response, and not only the average, but the 95% confidence interval within, because it's just like, because the monosaccharides that are being absorbed in our intestine are absorbed through specific transport proteins, you can saturate the ability of those transport proteins to take up those monosaccharides. And so you get a saturation point, right? It's not a linear increase. You see it just with enzyme kinetics that are saturatable. There's a certain concentration at which you can continue to increase exogenous carbohydrate intake without getting much absorption. And at least with that curvilinear response, the exogenous, on average, so this is just average, this isn't considering variation, you would need to consume around 163 grams per hour in order to realize, on average, around 95 grams per hour of oxidation.
That's pretty crazy, because when you start to then look at like power curves and do like the fatty acid oxidation sort of stuff, like for example, when we do the modeling for the Moxie trainalized assessment that I've been doing a lot now, at 200 and I think like 30 watts for me, I'm burning like 180 grams of carbohydrate per hour, which is like that's a lot of carbohydrate per hour. Even if I was intaking the 160, which we don't even know
exactly,
there might be some cyclists who can push like 150. At least that's kind of what I've heard through the grapevine. 150 is like a lot of carbohydrate. Like right now, I think I max out personally at like 90 and don't have any issues. When I was doing my ultra marathon, I was upwards of 100 to 110 and didn't have stomach issues. But again, it's like, okay, well, are you actually absorbing all of that? And
you'd have to be, or you would have stomach issues. And so
right.
Looking into the relationship between exogenous carbohydrate intake and gastric intestinal distress, there's not a lot of data to suggest that it's the carbohydrate per se. It tends to be the osmolality of the solution. It tends to be hydration status. It tends to be the exercise duration and intensity. So probably blood flow to the gut. Heat. Exactly. Yep. Those are all, and genetic predisposition. Do you know the most consistent predictor of GI distress during competition is GI distress during training?
Huh. I mean, it makes sense though, right? Like if you have GI distress, like, so, but also I want to say too that like, we are talking again about this is like, your diet outside of training is also probably going to change your ability to uptake carbohydrate.
I think you need, if you want to absorb a shit ton of carbohydrate, you need to eat a shit ton of carbohydrate.
Yes,
for sure. And that's it. I mean, if you think Thanksgiving was last week, you're probably going to hear this, I don't know, in January. So happy late Thanksgiving. We don't, guess what? I didn't get a stomach cramp from all that I ate, and I took in a lot of carbohydrate. And so it's the other, if you think about it, it's the other physiologic or other biological, physiological things that are going on that's going to then disturb your ability to digest and absorb those exogenous carbohydrates. And the sport currently, now this is anecdotal, but I would put my money behind this, the sport in which the athletes constantly take in without a problem that like at least 120 grams per hour, if not more, is cycling. and they eat everything under the sun. I have this
Mm-hmm.
picture that was posted on X. I love it. Literal hot dog, beer, 2 Oreo containers, a bunch of kind of granola, chugging pickle juice,
Mm-hmm.
and a beer. I don't know where the beer came from. Maybe to take the edge, and I don't know.
The beer's got carbohydrate in it, and it's all. I mean,
well, it has alcohol, and so you're going to preferentially burn that alcohol off. So maybe they do just a little bit of alcohol to try to even facilitate more glycogen storage,
resynthesis, because
right?
it's because
Possibly.
your liver is worried about processing the alcohol, not the carbohydrates.
I mean,
that's super interesting.
Yeah. And so I do think that when people talk about gut training, I used to just think, it's training your gut while you're training. I think it's large. That's true. That's part of it. But you also got to train your gut outside of training.
Mm-hmm. Yeah,
it's almost like the live high, train low model, right?
yeah, exactly, right. You know, you
live with high carbohydrate, train with low.
Well, and that's actually what people do then, right?
Yeah,
is they
exactly.
say, and you know, this is where it's like, the research gets interesting, because people have shown, okay, if you do a high intensity interval training day, you know, at the end, say like Wednesday night, and then you eat relatively low carbohydrate that day, and then go into, you know, the next morning and do, say, zone 2 training or something, you get superior benefits to fat oxidation compared to others. Yeah, that makes sense. But my question is, and this is what I've just been interested in thinking about, is like, is consistent training going to eventually lead to that fat oxidation compared to just, you know, like kind of stressing the system a little bit more because you have low carbohydrate? Like, you know, it's like, what's the balance of it? What's the optimal way to go about it? And is consistency of training going to get you 99.9% of the way there? And I think it's the training. It's doing that zone 2 sort of training. It's doing the high intensity training is going to proliferate all of these enzymes that are going to burn both fat and carbohydrate and get your body better at actually doing both, right? Because with more mitochondria, more functional mitochondria, you're just going to be able to rip through more substrate than you would if you know, than just like, because if your training suffers a lot from, you know, like being low carbohydrate the day after, then, you know, it's like, okay, well, your quality of training is going down. So, you know, like what's the trade-off there?
Yep. Yeah, I would really like to be able to measure skeletal muscle mitochondrial densities in these elite marathon runners. Because, you know, the average person has between 3% to 7% of their skeletal muscle that is taken up by mitochondria.
Mm-hmm.
I have a feeling that these individuals, it may be more around 15 to 20%.
It wouldn't surprise me, especially, I mean, Kelvin Kiptum is running 160 to 180 miles a week right now.
That's what I rode. That is what I rode last week. I rode 180 miles, and it was a heavier week for me riding.
Yeah.
Like, holy shit.
Yeah, and I mean, that's why he's able to run, I think a 2:34 was his, you know, is the
2 hours and 34 seconds.
Yes,
or 35 seconds.
Yeah. So it's just absolutely insane. And that's like the cool thing about looking at elite level endurance athletes is that you get to see kind of like the peak of the peak in terms of what can the human body actually do and what is it capable of. And when we take a step back, for most of us, we're probably in that like 48 to 52%, you know, like actually, totally. No, we're shifted up. We're probably like 68 to 75% in terms of, you know, like our adaptations if we are doing a lot of endurance training. But like those guys are like my dad, I think are they called 3 Sigma? Like so I don't, my dad told me a story about this guy who introduces himself, you know, they were in college or something like that. He's like, yeah, you know, Bob, whatever, 3 Sigma. And what he meant by that is that his IQ was 3 standard deviations higher than the normal person. So that's what I mean.
I hope your dad ended up fighting him.
No, I think what happened, my dad got a PhD and then he never talked to that guy again. So
Oh
it's
my
like,
gosh. Yesterday, because I was watching our podcast back, and I see a lot of things I say that makes me cringe. And I definitely was accurate in stating that I'm not gifted physically, but then I went on to say that maybe intellectually. That's probably not the case either. I was watching an interview with Elon Musk yesterday, and I was just sitting there and I was thinking, it's like, I wonder if the difference in my intellect to Elon Musk is more or less than like my physical capabilities from like a Kevin Kiptum or like a Jonas Vingegaard
right.
or Pogacar.
Yeah. What's the distance,
And
right?
so then I was like, maybe actually my intellect isn't any better relatively. Like, I'm
but
probably just average across the
But
board.
no. But the problem is, right, is that when you start to compare yourself to those like outliers, yeah, maybe you're, miles away from them. But it's like I told you I ran a 441
Yeah. And
mile at one point. But and for all intents and purposes, that's slow for a college runner. But in terms of human performance, that would put me at probably like the 98th 99th percentile,
yeah, oh,
right?
for sure.
So that's what I'm saying though, is like compared to the
Right.
population,
Right.
you're on the shallow end, or like the less steep end of the bell curve, at that point. In both cases, right? Like, even I think people would be amazed at the numbers, like I think we're up to 70% of the US population has overweight or obesity according to
Oh,
BMI, which is
brutal.
like, we know BMI isn't the end all be all, but
Right.
that's
But it's
that's a
good
lot
as
of
a
people.
population statistic because
Yeah,
it's not good when somebody has a lot of muscle. Well, guess
right.
what?
Not a
In
lot
a
of people have a lot of
country,
muscle.
a country of like 350 million people that
Right.
all have a high BMI, it's typically reflecting non-muscle.
Right. Yes. Non-func. I guess it's functional because it's doing something
Yeah,
for you.
but
But
that's so scary.
and then no, exactly. So and then what they say is, like, with cardiorespiratory fitness, right? You see improvements to, or reductions in things like cardiovascular disease, or other cardiovascular risk factors. Like, as soon as you're out of that bottom quarter,
Yep.
to get out of that bottom quarter, your VO2 max has to be like 30,
You're right.
maybe less than that.
Yep.
So, and then of course, like with every improvement, there's less and less bang for your buck in terms of VO2 max. But in terms of cardiorespiratory fitness, the higher you have that, the less likely you are to it lowers your all-cause mortality.
Totally.
Still.
I think there's epidemiologic research to show that somebody that does 15 to 20 minutes of vigorous activity a week, that's all that it kind of
A
takes to get out
week.
of that
That's
bottom 25%.
But yeah, and then look at, but if you just like go to the grocery store, look at the people around.
I know.
Like,
I know.
it
We
is
sound super
insane.
judgy right now.
No, and I don't judge an individual, because I don't blame them
Right.
for
It's
how they got to be that the way. I blame the system. I blame our ability to talk about exercise, to people. Like,
totally.
I believe that the pandemic and the shutdown was a perfect point for us to start talking about things like mental health and physical health. And we
Mental health
totally
is
just
tanking.
Oh yeah, and we totally just whiffed whiffed on that. It's like, you could have told people, like, as opposed to locking them in their houses, like, go and exercise. Try to exercise every single day. Be a part of a community, like, as much as you can, because we know that those are important. Like, try to change your habits now, because when we get done with this, right, you're going to be better off by being healthy and strong. Like, you can get pretty fit by having, and I know the indoor trainer, sort of thing, like, blew up during the pandemic. You can also get pretty strong. Like, my strength training right now is pull-ups and push-ups, just because that's what I like to do, and that's the only thing I have time to do. And you know, like I think comparatively, yeah, I'm not the strongest person, you know, in the gym or in the room or whatever, but I can do 40 push-ups in
The
a
room.
row.
Who
I
else is
am the
in that
strongest
room with
person in the
you?
room right now. Oh, just Bob. He's just sitting in the corner.
He's your security.
Yeah. He's making sure that nobody comes in and interrupts the podcast. Thanks, Bob. So no, but I can do, like, you know, I'm 168 pounds. I can do 40 push-ups in a row. Like, I feel like that's pretty good.
Okay, so I have one for you. This came across my X feed. And the question is, if there was, and this is hard because everybody's so variable, but for most people, an adult human, if we established that uh, all adults should be able to run 1 mile at this speed, what should that speed be? What is that kind of universally acceptable speed to be like, this person is probably somewhat metabolically healthy?
Oh man, that's
The answers
tough.
that I saw being
Yeah, I want to
provided
hear that.
were so much faster than I would have said.
I
So the
would
person
like
that posted it, they thought that it should be 8 minutes, an 8-minute mile.
that's actually pretty fast, and
That's
like,
pretty fast for a lot of people.
yeah. So my question is, though, is like, you know, so we're measuring cardio or metabolic fitness, right, based off of how fast you can run a mile.
Right.
I guess that's kind of comparable, right? You know, mile or 2 mile. You know, that's going to be generally done at VO2 max.
Exactly.
We know that, you know, the higher your VO2 max is, the more metabolic or cardiovascularly fit you are, at least.
Yep.
So then the question is like, okay, well, what qualifies us as healthy? So if we say, okay, if you're outside of that, you know, lower 20, 20, 25%, what's a decent walking?
I know.
Like,
And what are the weights of these people? Because, right,
Yeah.
the power that is necessary to run that mile are wildly variable.
Yeah, exactly. It's like, I think it's a fun little question to get people to engage on social media, but I don't think that that's necessarily like
It's
it
not
wouldn't be
appropriate.
it wouldn't be a 1-to-1, right? You know, it's like,
Yeah.
and I don't think 8-minute miles, like 8 minutes is like, that's cruising. I think you're starting to talk like 8-minute miles. That's like putting you in the top 75%.
I feel better
You feel
because, like,
validated?
yeah. Well, when I go, like, on my runs, like, am I good? I'm not just running 1 mile, but even if I did just run 1 mile, I bet you my fastest would probably be around 7.5 or something.
Yeah.
Averaging 8-minute across like 5 or 4 miles, that's good for me.
Yeah.
I work out a lot.
But that's the thing is, like, I think, again, speed
And I'm
also
a little higher. Elevation's
speed,
a little higher.
yeah. So I mean, I am too. I'm at 3,000 feet, and you know,
Are
so
you?
yeah, 3,000. Well, and that's why I asked you about like the exercise induced arterial hypoxemia, and if I have anemia and stuff. We're not talking about critical power and critical oxygen today. We're gonna keep going on this, and we can talk about that
good,
later.
because then I can finish reading this article when we do talk about
critical
perfect
power. Yeah. Let's keep going down this rabbit hole, because so there's a couple things I've been thinking about. So there's something that's floating around that's like, oh, for every mile you run, you burn 100 calories. That's, you know, like, I don't know what it was, but it's like, okay, it kind of makes sense, right? If you're faster and you run a mile, you burn 100 calories. If you're slower, you run a mile, you burn 100 calories. But I think all of that changes when you're going uphill or downhill, when you add elevation, because I've been wearing a Stride, which is like a power meter for your like running, and I can average going up that hill, and this is only a mile. I average like 300 watts going up that hill.
Oh, totally. I would totally believe. I bet you.
So
you
that's
could
not 100.
probably even do a little bit. Oh yeah, more. That's awesome. How do you feel that those are Stride or strides? Stride?
It's just Stride. Yeah.
Is it accurate? Do you feel?
See, it's hard to say because I can't. the problem is like, so what it does is it measures, I believe, your like your foot impulse.
Right.
And then I think you have to enter in your weight into
Mm.
like the app as well. So
Mhm.
it's taking into account your weight and then how fast you're moving it, right?
Right.
So I definitely think it reflects your mechanical output. The harder I'm working, the higher, the number is. I don't know though if it's then possible to say, okay, well, my critical power for running 280 is the same as my critical power for cycling 280.
Probably not.
But it's interesting because it's kind of close. So when I'm running up that hill,
really,
yeah, it's like, so I was telling you, I did that 1 hour FTP test, right?
yeah,
Because I was like, okay, I just want to see, like how, like what it is, what I can maintain for an hour, because that's what everybody talks about. 1 hour FTP test, 30-minute FTP test multiply, or 20-minute FTP test multiplied by 0.95, whatever. So I was like, okay, I'm going to go and do this. I'm just going to see how good I can do. And I started too low. So I was like, okay, I started at 230 watts. And I was like, okay, every 5 minutes, I'll bump up 5 or 10 watts. And then when I get to a point where I'm like, whew, then now I'm working. So over 30 minutes, I got up to 260 or 250. And then from there, I went from 260 to 320 at the end. But my longest average, I got about to 270, 275. And that's where I was like, okay, this is like, I don't know if I'll be able to keep going. So I think, I think my average was like 255 on the actual test, but I really think it's closer to like 265 or 270. And if I were then to go run, and I don't have my numbers exactly because I haven't reviewed them, but I believe that if I was using Stride, it would say when I'm running up that hill, and it would say that I think my average is probably about 300, and it's about 10 minutes to the top. So it's not quite, but it's a pace that I could maintain for, like if I go down and I come back up, and then I do a loop every 20 minutes. So I'll get like 3 to 4 minutes rest each time. And that's the pace I can maintain. I think 270 would actually be pretty manageable. And I think it makes sense because running up a hill is very similar to the muscles you're engaging when you're cycling.
Yes, that's what I was going to say. You stole my thunder. That's exactly what I was going to say. Is because it's primarily going to be concentric, right?
Right.
And so if you incorporate the parts of running that are going downhill or even flat, then you're going to be getting a lot more eccentric, and that's where running economy is going to be more important. And so whereas VO2 max and your thresholds, a lot more determining, explain a lot more variability in cycling performance. And so I think you're right. I think you nailed it right there at the end, is because that running up the hill in terms of muscle contraction and muscle reliance, very similar.
Yeah, it was just interesting because, it's like, and then too, right, you start thinking about, okay, well, I just ran on average maybe 250 watts for 40 minutes to an hour. If I was cycling at 250 watts for 40 minutes to an hour, that's what, another 600 to 800 calories or so that you're burning. So, so I've been going back and forth because I'm like, okay, well, yes, I'm only running 4 miles within this, but that's not 400 calories of effort. I'm redlining, like when I'm actually doing this, like 165 to 175 beats per minute. And I'm like, I'm doing quite a bit of work here. So that's where I think, like I think the 100 or the 100 calories per mile is a decent, like, just general rule. But I think, if you're actually breaking it down, it's based off of how much work you're doing, kilojoules, right? And kilojoules can be directly related to power. And, from there, if you're measuring power output, then you can kind of know. And maybe I am super inefficient, right? I'm my power output in terms of like converting that into like the mileage is off. But at the same time, I think that's where power is actually super valuable, is how many calories are you manually burning, per. And the goal is to try to reduce the amount of deficit you're in, as long as possible.
So there's something that's interesting that came about from that sub 2 hour marathon paper that I want to look at. Just so happens that the rate at which the modeled runners would be burning utilizing oxidizing carbohydrate. I wanted to compare our modeled values to values that have been published.
Mm-hmm.
And overall, I just had a sample size of 6, right? And two are from our modeling. So it's really just 4 other values. It's not a lot. But different studies, different protocols. The R squared, so the correlation, 0.99. Almost a perfect correlation across these values in terms of power output, overall absolute power output, and absolute rate of carbohydrate oxidation.
Mm-hmm.
Was that you?
No, that was you. You have a little
I didn't.
hand signal thing. No,
I
it's
do?
like, so based on, yeah, you can do things on hand signal.
Really?
Do this. Let's see.
Oh,
So Robbie is just
great.
discovering
now
that you can.
Now I'm lost.
So Dr. Jacobs is just discovering that you can do hand signals at the camera, and it will put emojis and stuff on the screen.
What did I just do?
That, go to the YouTube. I don't know what you did for the balloons.
I thought somebody hacked my phone. They're sending balloons. They're sending balloons in my screen. But I have I think I may be able to estimate about approximate carbohydrate oxidation at a given workload. But I'm like, but that doesn't make sense, because when you become more fit, you're able to maintain the same workload while burning more fat.
Right.
And so right now, this understanding, this new theory I have, it conflicts with current knowledge I have, and I am interested in resolving how they don't go together.
Yeah. I know it's really interesting now that I've started to collect data on myself again, like we were reviewing before this.
I was reviewing some of your data.
Yeah, no,
this morning. P. Miles Batterson Esquire.
Oh, see, you know what? I wanted to change your name on one of the things, so it was like,
R. Acton Jacobs Esquire.
Yeah, just to see if you would catch it. And no, I can't do that, because you'd totally be looking for it. But maybe just watch out. Anyways, we'll talk about that story in a while. So something that I heard Peter Attia talk to the other day or not the other day, but like on his Instagram, is he was talking about if you lined up everybody, on a starting line, and you had their FTP, and I don't know how he's defining FTP, but you had it in watts per kilogram, you would conceivably be able to tell who was going to win that race. Like, me coming from the predictors of performance, skeletal muscle oxygenation, other things. Okay, thank you.
Wrong.
Yeah. So
if it was,
I'm not going to go and attack, Peter Attia about this, but
purely uphill, then maybe he's onto something. But a flat course, it's absolute power. Absolute power is what you want when it's flat.
And you mean absolute? Yeah.
You're absolute, like 200, 250 watts, and it's flat. Yeah. And if it's going downhill, that is going to be the stronger predictor. If it's going uphill, then we can start talking about watts per kg as a stronger predictor.
Yeah, because that's another thing that I've been thinking about a lot in my head is cyclists are especially guilty of this, is everything is watts per kg, because it's like you got to compare it to other people, right? Say we do the same thing with VO2 max, which is, I think it's totally valid. However,
I'm starting to use more and more and more absolute VO2 maxes. Yeah. Like in the sub 2 hour marathon paper, I just report VO2 max across our modeled runners as well as what's in the studies as absolute. It's very valuable. I actually am finding more and more value in the absolute measures than the relative measures.
Well, yeah, because if you start thinking about it, right, you start, if you're comparing within individuals, right? It pretty much is going to wash out, because you're not going to have tons and tons of variability in weight and other things like that. But if you start to look, like I had a guy approach me, and we talked about he did some VO2 max testing, and his absolute VO2 max was like 6 liters or something like that.
Woo-wee.
Yeah, he's a beast. And so he approached me, we talked about it, and he was like, man, I don't believe that, because like his like performance times don't translate in a sense. But he's
right.
like, he's a big muscular dude. He's like 84 kilograms in
Right.
terms of weight.
Yeah.
And he's been running a lot now, and I'm like, man, maybe all of that bodybuilding work kind of led to proliferation of your mitochondria, because
Sure.
that is a big bioenergetic stress.
Right.
So you could have probably very, very high total oxygen consumption within your body, but maybe you're just not you're not economical for it yet, because you haven't trained in running a lot. So it was just really interesting, because I was like, holy crap, dude, like if you just look at it, he had like a 77 or 74 in terms of his relative VO2 max. And yeah,
I'm
right.
happy
No, I
when
know.
mine kicks above 60.
Yeah. So I was just like, I was like, well, let's just assume that the data is correct, because he went and he got it collected, at a university and stuff. So I'm like, okay, like let's try to believe, that's correct. What does this actually mean for you? And this is where, I think, people try to, again, simplify all these measures and all that sort of stuff. And when we say, oh, well, my VO2 max is 77, so I should be able to run a 14-minute 5K, even though my PR is 18. Right? It's like, no, it doesn't, because there's something going on that is causing you to be inefficient, or maybe your threshold isn't high enough, like other things like that. So that's where you need to take into account extra variables.
Totally.
But I want to keep going with that absolute versus flat. So have you
just
ever
on your
calculated,
paper? So on your paper for your relative is higher than absolute. But not by much. So just the direct correlation, a little over 50% correlation with performance, with relative VO2 max and performance, and absolute is 46.4. But I couldn't remember if it was absolute or relative that actually made the number one, the tightest, the best predictor combination of traditional variables. I believe it's absolute VO2 that was identified.
Well, what about for like the second threshold? Is it reported relatively, or is it reported absolutely?
It is percent. It's where in the percent of VO2 max that it landed. But the second one, the second best combination is relative VO2 and absolute measures of VO2 at threshold.
Mm-hmm. Yeah, because that's like that. Everybody talks about watts per kilogram, and I wonder. So yeah, on a flat course or a downhill course, that shouldn't matter that much. Like, how much of a difference does, say, like 5 pounds make if you're riding on a flat course? That's what I want to know.
I don't think much.
It can't be that much, because you're not increasing rolling resistance on your bike that much by adding a little bit of extra weight. It's more the type of bike you have, and all of that. So your engine, your body, right? It doesn't matter if you're 170 pounds or 160 pounds. That's not going to be the difference. Yes, when you're going uphill, absolutely agree that watts per kilogram is super important. And most races are pretty hilly. But at the same time,
they have flat and they have up,
right? But at the same time, so my question then, my second question would then be, so if you're going up a hill, what's the steepest grade that you'd cycle up? Probably 20%, maybe. Like that'd be a super brutal, steep grade, right?
Right.
So if you're going 20%, that means you're only getting 20% of your weight as a downward force. So if we're breaking them into vector forces and stuff like that, let's think back to like freshman physics. Oh man, that was a nightmare for me. Revisiting the trauma.
Me too. Is one of my only B pluses.
dude. Yeah, I would have been happy with B pluses in my physics.
But I took the non-major. I took the non-engineering physics. So you took the engineering physics, and it was a nightmare. But I loved it. It's cool though.
No, it's super interesting when there's actually a teacher that can teach it well.
Exactly.
So you're only feeling, say, 20% of that force, right? Or you know, whatever the you know what I'm talking about. So even then, we'll assume it's 20%. If you're 10 pounds heavier than somebody, that's 2 extra pounds that you're carrying, you know, up that hill. And yes, you know, so then if you add it up, if someone's 130 pounds and they're, you know, really, really strong, and you're 160 or 200 pounds, then it starts to add up. But, you know, like, but that's where I struggle. I'm like, man, I would rather be strong and get the extra power output from being stronger and being a little bit heavier than try to cut a bunch of weight and, you know, be thinner for it, right? Because that's also a miserable existence if you're trying to cut weight and gain performance at the same time.
Yep.
So,
and guess what? I may or may not have some data that I am close to getting submitted for publication that shows different biological characteristics that may or may not be more important for maintaining absolute power versus relative power.
Okay. Well, that'll be another journal club we'll have to do. I'm super excited about this. This is the sort of stuff that, you know, we would do during my masters, is just shoot the shit and just, you know, talk about all the science.
I could talk about this all day long. I love this stuff.
I know it's awesome, because these are all things that I've been thinking about, you know, like while I run. And, you know, like we were going back and forth. We were like, well, what would the best, you know, like ratio and stuff of like nutrition actually be, and how much should you be consuming, and all of this. And it's really refreshing to be able to actually like talk about this, because I was thinking, like, I had on my list of things, I was like, is watts per kilogram actually, you know, what we should be striving for? And there's like, you know, so this is where research kind of gets like turned a little bit. So there's a paper that was looking at CrossFit performance, and it compared a bunch of elite level CrossFitters that did, you know, like VO2 Max.
Okay.
Yeah, like VO2 Max, like second threshold, like all this other stuff. And the only thing, like, you know, 1 rep max back squat, like I can't even remember. But their biggest thing was like, they're like, yeah, the single best predictor of performance was body fat percentage.
Oh yeah. I see a lot of that too. I saw a very strong correlation with body fat percentage in these elite endurance athletes.
But here's my thing is I don't think body fat percentage is making you perform better. I think it's your performance and all of the work you're doing is allowing you to have a low body fat percentage.
Totally.
So if you read that paper though, right, a lot of people would interpret that to be, oh shit, I gotta do body recomposition. That's gonna make me a good CrossFitter.
Not at all.
No. You need to consistently work hard for extended periods of time.
Yep.
And eventually what's going to happen is you're going to build up so much muscle, and, you know, as long as you're eating correctly and you have, you know, adequate nutrients on board, you're going to then start to lose body fat because you're training so hard that eventually you get down. So it's like, you know, so it's like, you know, what came first, the chicken or the egg? In this case, it's like body fat percentage follows consistency and performance and all of that, and eating adequately. So,
but the wild thing is, so if you just took everybody that's lined up for the race, and I forget what these are now, because I'm so steeped in the sub 2 hour marathon paper. It was the predictors of performance across sex that I was doing before, and I need to remember, but there were like 3 anthropometric measures that if you already had the homogeneous sample of all athletes, that then you apply these very basic anthropometrics, and
like how big is their chest cavity? Like
it's
is their hand,
I think it's,
you know,
body
what's
mass.
The distance between their thumb and their pinky?
It's like body mass, the ratio of body mass to fat mass, and something else. It's these ridiculously basic characteristics that really separated the performance across these athletes really well.
Right. And it's, again, but that's not stuff we can control, right?
No.
You know, so it's like, okay, cool. Like, you know, what did we learn from it? Yeah, I'm not going to go and make my hand bigger, you know, like the ratio of,
well, you know, the biologic characteristic that was tightest with the lowest body fat?
What?
It wasn't even lean mass. is mitochondria. It was
See, but then we
respiratory
can,
potential
but then
was
we can,
stronger
but
than
then we
even
can start
muscle.
to make the case, right, that
Totally.
because your mitochondria are stronger, you're able to oxidize more fat, most likely. So it depends on how body fat is measured, because most likely what's happening is you're actually packing more fat into your muscle. So then it's actually used as metabolically active energy, production, as
Yeah.
opposed to just sitting there. I keep wanting to say inertly on your body, but it's not. Like having adipose tissue, it's a signaling organ. It's excreting things, it's taking in things, it's reacting to things,
Just like the muscle.
just like the muscle.
Yep.
So I keep wanting to say, that, but it's certainly not. And I think though at the end of the day, but okay, practically, how easy is it to actually get your body fat percentage measured? It's really tough. Like there's not places around that you can go and get like a DEXA scan that's actually cheap. You can also mess up a DEXA scan really, really easily. And then you're like, oh, well, am I actually 30% body fat? Because, like, so it's challenging from that perspective as well. And I think like, again, I think people lose track of, like what we really need to do. And I think, from a performance perspective, and this is ever since, you and I started talking about mitochondria, I think developing robust mitochondria is probably the single best way of developing everything. Yeah, even in my master's thesis, right, I had the three circles that were all overlapping, and we pointed towards the mitochondria, but most likely it's that capillary myoglobin mitochondrial axis. So developing that to the best of your ability, by going slow,
The
going
axis
fast,
of oxidation.
Oh, that sounds like a super a villain group. The Axis of Oxidation. Watch out, we're coming for you. I love that. Oh my gosh, that is.
Dang it! I had something. Of course, it seems more important now.
No,
But then
the
that
Axis of
stupid axis of
Oxidation
oxidation popped in my head.
Dude.
Oh, you know what we should do a podcast episode about is what are mitochondria and where'd they come from? Because when you consider the evolution of life on this planet and what made it possible, you're kind of like, oh, okay, it kind of does make sense,
right?
That mitochondria do kind of serve as this canary in the coal mine for overall human health and performance. Yeah.
Yep.
It's because that component was necessary for our cellular ancestors to even become multicellular and a more complex biological entity.
Yeah, there was a talk that I went to, I think at the International Biochemistry of Exercise conference. That was like,
so jealous you went to that.
It was like mitochondria, the powerhouse, the slaughterhouse, and the something else of the cell. And I was like, holy shit, that was amazing.
It was a good talk.
Like, just the title, I can't remember if the talk was good, but the title of the talk was sweet. So yeah, no, I think where I want to go, with our conversations for the listeners and stuff, is that the next one we're going to talk about critical power and its relationship to a new term called critical oxygen or critical oxygenation, which is what the podcast is named after.
Exactly.
And then after that, let's go into some serious mitochondrial physiology, because mitochondria aren't just the powerhouse of the cell, and we talk about them all the time like that. But if you ask anybody, I've started probably like 3 or 4 lectures off with like, mitochondria are the blank, and then I have people yell it out and they're like, oh yeah, and I'm like, did you also know mitochondria are this? And then it's just like crickets. So I think, and I trust that our listeners are a little bit more educated than that, but this is in a room of like, potential PhDs and master students and stuff.
Totally.
So yeah, I think let's go that way. Let's start to dig in on this axis of oxidation, and we can go from there, dude. I like that too. Actually, I love that. Oh my gosh, yeah. I'm gonna make some. I'll do some DALI 3. Make the axis of oxidation.
Yeah,
it'll be perfect. All right, guys. We will leave you guys there. I think this was a great. It's not working now. I think this was a great episode. Oh, did it work? Okay. If you're interested in what I was just talking about, you're going to have to go to the YouTube video. But You can catch me, as always, at Critical02. If you have any questions, comments, or anything like that for both Robbie and I, let us know. I'm going to start tagging him on his Instagram.
Actually, you know what? If people want to connect with me, they should find me in Zwift and ride with me. That's what they should do.
Hell yeah. That's cool. So another thing. So connect with Robbie on Zwift. What's your username?
It's R Jacobs, and then in parentheses 2,000 meters, because that's what I'm riding at. So if you're faster than me, just remember I'm at 2,000 meters. But if you're not faster than me, remember I'm at 2,000 meters.
Perfect. And and also quick reminder, Aaron Geyser, who's another co-host on the podcast, runs a long ride every Saturday for individuals who are interested in doing that.
Yep.
So go ahead, check that out. Team up with Robbie. I might have to go to Zwift at some point. I use a lot of full gas for my stuff.
And I'm going to be riding a lot harder to try to keep up with Phil.
No. Okay, maybe not then, because I don't want it to be a competition. I just want
it's not. It can't be. It can't. I could not hang with you now. You've gotten.
I'm kind of on one in terms of my biking.
But you should be.
Get my biking fitness up.
This is where you should be when you're talking about what you're able to do as a runner.
Well, I think cycling, actually, I might be able to tip the scales a little bit, because I can stay healthy in cycling. That's the biggest thing for me.
But do it. Get on Swift. We'll ride. We'll do some rides.
Yeah, it'll be fun. So check us out. Maybe me on Zwift. Definitely Robbie. And do you want to leave the listeners with anything today?
Oh shoot, I wasn't even thinking about that. Train your gut.
Boom. Train your gut, and we'll catch you guys in the next one.